Hi everyone, today we're starting chapter 6 and we're looking at section 1, which is going to help us to start to think about systems of linear equations. A system of linear equations is when we have more than one equation that relates to the same set of variables, and there are unique representations of those variables. So a good scenario to think about is this number 1. Gwen has a part-time job working at Relatable Robots, and they sell electronics and hardware. So she's got two different things that she needs to think about: the cost of purchasing the components as well as the profit that she's going to make. So what I want to know in this first scenario is, what is the break-even point of that information? If she's putting an investment into the company and there's a cost that she has to pay as well, at what point will those two variables meet? And basically the same amount of money she put in, she's getting out. So we want to look at what relationship is going to show the break-even point. So when you think about the solution to an equation, it's where we have an input and an output that make the equation true. So if the function for the income is equal to the function for the cost, then the income equals the cost for the same number of gears sold. So you break even. So no matter at that certain point, no matter how much money I put in, I get out the same amount. Part B says, what relationship will show profit? So when I think about income compared to cost, I want to make more money than I'm spending to run my business. So when my income, the function of income, is greater than the function of cost, then I'm going to have a profit. I'm earning money. So number 2, says the robotics relation gets gears for $5.77 plus a one-time credit card fee of $45. And we sell them for $8.5 per gear. So when I'm looking at setting up a system of equations, I want to make sure that I have both of those functions, and that way I can sketch a graph and look at the relationship between the two graphs. So I type in both my functions, and then I'm going to zoom fit my data. Now, presumably, I'm never losing money, so I'm going to adjust that to be just quadrant 1. But at this point, I'm only seeing one line, which isn't very helpful. So I'm going to adjust my scale so that I'm looking at about the cost of 50 gears and thinking that I sell them for $8 a piece. My y-axis should go to about 400. And now I have a pretty good picture of my graph. So I'm just going to sketch my axis. We'll speed this part up a little bit because you know how to graph two lines. I'm labeling my x-axis by 5s, my y-axis by 50s. Again, if the cost of a gear is about $8, then I want to be comparable. I have my lines. I'm just going to approximate a couple of those points for the income, or for the cost, and then for the income. And it's okay if you're not perfect. This is just an image to give us an idea of where the lines are, what we need to be mindful of. So I've graphed both of those functions, and now I'm going to do some interesting things with my calculator. If I do second calc, I can calculate the intersection of the lines. That's the point where each line has a solution and it's the same solution. So it's basically where those two lines intersect. Now my picture is not as great as my graphing calculator, but it's approximately at 16 gears, and the monetary value is about $140. The other thing you could do is go to second table and get a really good picture of what those data points look like, and that way your graph is more accurate. But again, for the most part, we're estimating. So right now we're going to take a break and pause your video so that you can complete the Chapter 6 classwork. And I want to leave a note for you that you should use your video notes as a guide to go through that Chapter 6 classwork. And then in addition, I want you to be mindful that you can substitute variables x and y in a function when utilizing a calculator. So as opposed to saying the function of income and the function of cost, you could just say y is equal to 8.5x, y is equal to 5.77x plus 45. We don't have to worry about renaming our variables. Just make sure that you keep track of that information. So after your Chapter 6 classwork, you're going to come back into your notebook and you're going to answer the following exit ticket, which says, where does the break-even point or the solution to a system appear on a graph? And I want you to describe the location of your answer. If you were to look at your graph, where do you see the solution to the system of the equation?